I will evaluate the integration of this rational expression by partial fractions. Let me first take out the rational expression in order to resolve it. Notice that this is a proper fraction in that the numerator is power 1 and is less than the denominator, which is of power 3. So observe that I have a linear term in the denominator and a repeated linear. So when I break it up, I will have a linear denominator and the repeated linear. We will have to repeat and reduce the power. A linear denominator will always have a constant numerator. Repeated linear denominator will also have constant numerators. The numerator of a linear denominator can be solved by carve-out rule. The numerator of the repeated linear of the original form, meaning power 2, because it's power 2, also can be solved by carve-out rule. This is a repeat of this, therefore this cannot be solved by carve-out rule. So to find A, I will copy the expression and cover x plus 2. Whatever I covered, which is x plus 2, I'm going to equate to 0, so x equals to minus 2. So I have a minus 4 over 9. Do the same for b. To find the value of b, I have to cover x minus 1 squared. So whatever I covered, which is x minus 1 squared, let it be 0. That will make x equal 1. So I have a 2/3. Now to find the value of c, I will have to remove all these fractions. So I'll take this denominator and multiply across. Denominator, multiply across. So I will now take this term and multiply to each of these fraction terms. So take the first fraction and multiply to this term. Can you see that x plus 2 will cancel with x plus 2? I'll be left with this. The second fraction term, multiply to this term. Can you see that x minus 1 squared will cancel with x minus 1 squared? I'll be left with this. This fraction term, to multiply to this term, x minus 1 will cancel with one copy of the x minus 1. So I'll have x plus 2 and one more copy of the x minus 1. Now expand this completely. So to find the value of c, I'm going to compare the x squared terms. So I look for the x squared terms. So on the left side, there's no x squared term, therefore the coefficient is 0. On the right side, you have a ax squared, coefficient a, and a cx squared, coefficient c. Since I know the value of a is negative 4 over 9, hence c equals to negative a, which gives 4 over 9. So with these values of a, b, and c, I'm now going to solve the integration. So I'm going to take these partial fractions and put it into the integral instead. I have a over x plus 2, where a is negative 4 over 9. I have b over x minus 1 squared, where b is 2/3. I have c over x minus 1, where c is 4 over 9. So let me rewrite this in a way that is easier to see in order to integrate later. So this is just simply logarithm. So it is the ln of x plus 2. For this, I increase the power by 1, which is negative 1, and divide by the new power, which is negative 1. So change to negative 1, divide by negative 1, I'll have a negative 2/3, and immediately I write it as the reciprocal. And again, this is a ln. And that's it.